Okay, welcome back, to class. We are still going to be continuing over reactions. That's what we were looking at before we left for break. Now, some of you might have left us at school because, didn't think that we'd not coming back, so I will be posting this onto Canvas as a PDF so that you have reference for it. It is the solubility rules sheet that I gave to you before break, and we're going to be looking at the right hand side of it, that is dealing with what is called the activity series. Now what I'm going to be doing is I am going to be kind of talking through the notes and everything on video and be posting them to YouTube. I will also be making a PDF form of the notes that I write down for you so that you have that in your possession as well. So you can kind of look at this video as many times as you need to, look at the notes and everything. Have any questions, please contact me, send me an email. So with the activity series, this kind of shows us whether a reaction is going to take place or not, because we can write down reaction after reaction and think, okay, this is going to happen, but sometimes it doesn't. So with the activity series list, looking at it, we have mainly a list of metals going all the way down. Then down the bottom we have our halogens, and off to the side it has some information about it. So in our first list it says, reacts with cold water and acids replacing H2 and reacts with O2 forming oxides. Okay, so that's telling us that those are what they mainly react with. So we kind of look at that. Reacts with cold water and acids replacing hydrogen. So if we look at let's just take our first element that's up here, lithium. So we're going to take lithium as a solid. We're going to react it with an acid. Let's just use hydrochloric acid. And it says replacing hydrogen in the reaction. So if we kind of look at what we're doing before, figuring out what our products are going to be, lithium, we have a +1 charge as an ion. Hydrogen has a +1, chlorine a -1. So lithium is going to go with chlorine. Give us lithium chloride, LiCl. And if we look at our solubility rules, chloride's all soluble except with silver, mercury 1, and lead 2. Lithium's not one of these exceptions, so lithium chloride is going to be aqueous, and hydrogen's going to be by itself, so we write down as diatomic hydrogen, H2, and that's going to be in the gaseous form. Okay, and we can do that for any of these. If we just look at the box and everything, see if it's going to happen or not. It's going to react with those kind of compounds. Now, the other way that these can help us is you see how the metals are listed. They're not listed in increasing atomic number. They're listed in way of activity possible, since it is called activity series. So let's kind of look at an example. Let's say, let's use chromium, solid, and let's react this with lead 2 nitrate. Okay, so now if we look at this, this is a single displacement reaction. Element reacting with a compound. So how can we use the activities to see if this takes place? Well, the way that we do that is we look to see where the two metals are at relative to one another. So here is chromium and here's lead. If the element that is by itself is higher on the list than the one that is in the compound, the reaction takes place. So chromium's up here, lead's down here. Our reaction is going to take place. So we can proceed with figuring out what our product's going to be. So chromium usually has a +2 charge. Lead, in this case, +2 charge. Nitrate, -1. So the chromium goes with nitrate. So we're going to get CrNO3, 2, and all nitrate compounds are aqueous, plus lead is going to be by itself, so it's going to be in the solid form. Now, let's just kind of pick some other ones. Let's say we have nickel, and let's react that with, let's say sodium chloride, and this can be in the aqueous form. Okay, so now if we look back at our activity series, we have two metals once again. We have nickel, which is right here. We have sodium, which is way up here. So nickel, the element by itself, is way down here, and sodium is way up here. So since nickel is lower than sodium on the activity series, nothing's going to happen. No reaction. So we don't even need to figure out what our products are going to be in this situation. Now for the halogens, we can kind of do the same thing. And if we look at the list, it says listed from most reactive to least reactive. So if the halogen by itself is higher on the list than the one in the compound, it's going to take place. Let's kind of look at an example of this. Let's say we have chlorine gas, and that's going to be reacting with, say, aluminum bromide. Okay, so chlorine, bromine. Chlorine, since it is by itself and it's higher on the list than bromine, which is in the compound, our reaction is going to take place. So chlorine has -1, aluminum has +3, bromine -1. So aluminum is going to bond with the aluminum. So we have AlCl3, and that's going to be aqueous, plus the bromine is going to be by itself, so Br2, and since bromine is a liquid at room temperature, we put an L. Now one of the things we haven't done with these is we need to balance the reactions again. So let's kind of review over balancing reactions real quickly. So step one is balance all the non-hydrogen oxygen elements first. Okay, so one lithium, one chlorine, one chlorine. So right now we're good to go. Now step two is balance hydrogens. We have one hydrogen, two hydrogen. So we need to put a coefficient of 2 on front of HCl. Now that gives us two chlorines on the left-hand side. So we need two chlorines on the right-hand side. So we're going to put a coefficient of 2 in front of lithium chloride. Then now we need to put a coefficient of 2 on front of lithium. If we go down to our next one, one chromium, one lead, one lead. So we're good to go there. Now if we look, we have two nitrates over on the left-hand side because of that 2, and we have two nitrates on the right-hand side. So everything's already balanced for this one. Our third one, no reaction, we don't have to worry about that one. Now, our fourth one, chlorine. We have two chlorines on the left-hand side. We have 3 on the right. So to balance this out, let's get 6 chlorines. So we're going to put a coefficient of 3 in front of diatomic chlorine and a coefficient of 2 out in front of aluminum chloride. Now that gives us 2 aluminums on the right-hand side, so we need 2 on the left. So So 2 aluminum there, that gives us 6 bromines. So we need 6 bromines on the right, so we need a coefficient of 3. So that's how you work with the activity series. And on the assignment that I have posted along with this video, this is what you're going to be doing. So the first part, using your activity series, figuring out if the reaction is going to take place. If it does, figure out what your products are going to be. Use your solubility rules. Now, the next part is, with these reactions, if we have something that's aqueous, it's not really hanging around as a compound total completely. It's actually floating around as ions. And what we can do is we can show what is floating around as ions and what's actually doing the reaction. And these are called complete net ionic reactions. So let's kind of look at an example of a complete net ionic reaction. And for this one, let's use hydrochloric acid reacting with lead 2 nitrate. Okay, so now we figure out what our products are going to be. Let's break everything up, since this is a double displacement reaction. Hydrogen has +1, chlorine -1, lead has a +2, nitrate has a -1. So hydrogen is going to bond up to nitrate, so we're going to get HNO3, and that's going to be aqueous, plus, then the lead's going to go with the chloride, PbCl2. Now, how do I know that was aqueous? All nitrate compounds, aqueous. Now, PbCl2. If we look at our solubility rules, chlorides, all soluble except with silver, mercury 1, lead 2. So that's this one we're going to put down solid. So since at least one of our products, or one thing in the reaction is solid, not aqueous, we can figure out our complete net ionic reaction. Let's balance this real quickly. Okay, so 1 chlorine, 2 chlorine, so we're going to put 2 right there. 1 lead, 1 lead. Okay, so those 2 are balanced, but now we got hydrogens, 2 hydrogens, need 2 right there. Then we have 2 nitrates and 2 nitrates. Alright, so the first one that we're going to write out is the complete ionic equation. With the complete, we show everything. And if it's aqueous, we break it apart into ions. Coefficients go along with this. So since we have coefficient 2 in front of HCl, we're going to have 2 hydrogen ions plus 2 chlorine ions. Okay, lead 2 nitrates aqueous, so we have to break that apart. We're going to get 1 lead 2 ion and 2 nitrate ions. Now, why did I only put 1 lead and 2 nitrates? Well, if we look at our formula, we only have 1 lead because there's no number after it. And nitrate, since we have that parentheses around it, and 2, that's telling me that we have 2 nitrates. Okay, now we're at our arrow. So now the products, okay, HNO3 is aqueous, so we break it apart. That coefficient 2 tells us we have 2 hydrogen ions, 2 nitrate ions. Now PbCl2 is in the solid form, so we're just going to write it down as is. Anything that is solid, liquid, or gas, do not break it apart. Let me say that one more time. Anything that is a solid, liquid, or gas, do not break it apart. So this is our complete ionic equation. Now the next thing is we need to see if we have any spectator ions. Okay, spectator ions. Ions found on both sides of the reaction. Now, spectator ions are just like spectators at a sporting event. They're just there, they're not doing anything. They're not scoring any points or anything like that. And spectator ions will look exactly the same from the left-hand side to the right-hand side. So if we go back up and see if we have any spectator ions. Well, we have 2 hydrogen ions on the left. We have 2 hydrogen ions on the right. So our hydrogen ions, our spectator ions, we're going to cross those out. We have 2 chlorine ions on the left, but we don't have any 2 chlorine ions on the right-hand side. So that's not a spectator ion. We have a lead-2 ion on the left, no lead-2 on the right. We have 2 nitrates on the left, and we have 2 nitrates on the right. So we cross those out. And once we get done crossing out all of our spectator ions, anything left over is actually doing something in the reaction. So we write that down for the net ionic equation. So our net ionic equation for this one, we have 2 chlorine ions plus 2 lead ions yields 2 PbCl2. So it's just a way of showing what is actually doing something within the reaction. Let's look at another example. Let's see, what do I want to use? Okay, I got an idea. Let's use sodium carbonate, aqueous. Let's react this with sulfuric acid. Okay, now I'm just going to go ahead and give you what our product's going to be. Na2SO4, that's going to be aqueous plus CO2 gas plus H2O liquid. Alright, so now let's look to see if it's balanced. 2 sodium, 1 carbon, 1 carbon, 1 sulfate, 1 sulfate, looking pretty good. Then we have 3 oxygens minus the 4 from the sulfate. So O2 plus O, 3 oxygens, 2 hydrogens, 2 hydrogens. So it's balanced for us. Now we're going to write out our complete ionic equation. So let's figure out what our ions are going to be. Well, sodium, since it's in group 1, has a +1 charge. Carbonate has a -2. Hydrogen has a +1. And sulfate has a -2. So sodium carbonate is aqueous, so we have to break it apart. Now we have 2 sodiums up in our compound, so we have to show 2 sodium ions. We have 1 carbonate ions, so CO3. Get 2 sulfuric acid, we have 2 hydrogens, so we have to show 2 hydrogen ions. And we have 1 sulfate, so show 1 sulfate ion. Now over on the right hand side, sodium sulfate is aqueous, so Should break it apart into ions. We have 2 sodiums, so once again we have to show 2 sodium ions. We only have 1 sulfate, so show 1 sulfate ion. Now our last 2 products, we have carbon dioxide and water. Gas, liquid. Write them down as is. We do not break them apart. So we have that. Well, let's see if we have any spectator ions. Well, we have 2 sodium ions on the left. We have 2 sodium ions on the right. So we're going to cross those out. We have a carbonate ion on the left-hand side. We don't have a carbonate ion on the right. It has to look exactly the same. I know carbon dioxide looks very much like carbonate, but they have to look exactly the same. We have 2 hydrogen ions on the left, no hydrogen ions on the right. Then we have a sulfate ion on the left, and we have a sulfate ion on the right. So that's another spectator ion. Okay, after crossing out all the spectator ions, next thing is to write down the net ion equation. So our net ion equation is we have a carbonate ion plus 2 hydrogen ions yields to carbon dioxide plus water. Okay, so what I'm going to do now is I'm going to stop this for right now, and you can look at this video as many times as you want to or need to. Try to do the first 2 parts of the assignment, the activity series part and the net ionic complete ionic equations. I will post a key next week, and if you have any questions, let me know. And if there's a lot of people that need help with this, what we will do is we will set up a WebEx meeting so that you can see my face and we can kind of talk through things in person somewhat over the internet. So I hope this was beneficial, and I will talk to you later.